I'll share my screen. 1 second. All right.
This is chapter 4 and 5, right?
Sorry?
This was chapter 4 and 5, right? Or 4?
I think it's just chapter 5. Yeah.
Okay.
I don't have the syllabus on me.
Okay. No worries. You're okay. Don't worry about it. I was just making sure we were on the same page.
Yeah. It should be about like fractions, squares, and square roots. So.
Okay. Perfect. Yeah, because I think chapter 5 is statistics or something.
Yeah, that was the most recent one. I think it was like chapter 5 and 8 for
Okay.
like the newest one.
Okay.
But yeah, this was like, so yeah, basically like it goes into like fractions. So like it's a fractured number. Always kind of has the form of a whole number over another whole number. So like, any type of fraction. It goes into like numerators and denominators. But like everybody knows what those are. Then it kind of goes into like improper fractions, where the numerator is bigger than the denominator. And you got proper fractions, which are just normal fractions. The numerator is smaller. And then like mixed numbers, where you're taking an improper fraction and making it proper. So like taking 14 over 5 and making that 2 4/5. Yeah. And then like kind of goes into like, some fractions, they can be simplified. So like 8 over 10 is equivalent to like 4 over 5. And then like mathematicians refer to fractions as rational numbers, because they're like ratios of two numbers. Then it goes into like adding and multiplying fractions. Yeah, so like for multiplying, you're just multiplying like on each side. And you're getting 1 times 4 over 2 times 5. And then for adding, it's a little more complicated. You have to find a common denominator. But yeah, with that like example, it's kind of easy. Then like converting fractions into decimals, like using the 4/5, 8/10 kind of example. So like, because like 10, so you're doing that's just 0.8. And it's like easier to do with 5 and 10 as the denominator, but something like 7/8's kind of harder. It has like this like procedure of doing it, but calculators exist, so I think it doesn't. It went into a little more, which I understand because it's like the reading, but yeah, just like calculators exist. So then like going into that a little more, goes with like recurring decimals. So like 2/3 is 0.6 repeating. And like 5/7, the recurring decimal is like 0.714285. So you just put a line over that, kind of like how you'd put the line over the just 1/6, since that's the repeating decimal. And then it goes into like Egyptian fractions, which were kind of interesting because it was a different way to like calculate 5/7, because they didn't really have that computing power, like knowledge of that, of like how to do that, kind of like how we do it. So they took regular unit fractions and they just added them up, and eventually getting 5/7, which kind of interesting. But then it like going into like chapter 4, it goes into squares. So like square numbers are perfect numbers, like 1, 4, 9, 16. It's basically just adding multiplying two numbers by itself, or one number by itself. And then you kind of have the same thing for like triangles, pentagons, other polygons. And it kind of goes into like, so triangles and squares are both pretty much like, they both have 36, and they kind of bridge that into, they're actually really similar, triangles and squares, because if you add two successive triangular numbers, you're getting a square number. Like 1 and 3 equals 4, or even like 1 plus 9 is 10, which is a triangular number. And then that can go the other way. So kind of like what I did here. If you're drawing a diagonal line through a square, you're going to get two triangular numbers, like this 9 thing that makes 3 and 6. Yeah, but basically like side of a square is x, the area is x squared, and like x squared is the basis for like a parabolic shape, which is like a different aspect of math that it doesn't go into. And then you have like square roots. They've been used since like the 1500s. Like, yeah, all square numbers are basically whole numbers as square roots. And just like how x squared is a square number, you're halving that, so it's x 1 over 2 is a square root. And I forgot to do the square root symbol. But yeah, square root of 2 is important because all we'll ever get is an approximation, and it's called a Pythagorean number. And then it goes into like, are square roots a fraction? I kind of just generalized it into like, is square root of 2 a fraction? Basically, it's assumed that square root of 2 can't be a fraction, but it can't not be a fraction at the same time. It's like a Greek law of logic called the excluded middle. Yeah, it can be proved that the whole sequence of square root of n, except when n, which basically just means number, is a perfect square, cannot be fractions. And numbers that can't be expressed as fractions are irrational numbers. And yeah, that's all I had.
Awesome. I had the notes on my phone here.
Awesome.
Here. Yeah, so for this chapter, I know you went deeper into like the actual like math side of things, I guess, and I think my biggest takeaway from this was more so just based on like I guess the logic behind it and like the point and use of fractions, and basically the one thing that I came to conclusion with was just was the fact that fractions are basically meant to simplify a number as much as possible. It was basically like you were saying, if it's 8 out of 10, it would be, what is it, like 4 out of 5, that sort of thing. And just doing that, and then obviously we use that now with trying to find like percentages and whatnot. And I mean, I guess that's kind of what all of math is just trying to get the simplest, most like reduced version of some sort of numerical issue that we face. And yeah, so let me see here. Okay. Yeah, it's interesting too, because I took notes here, but I'm trying to find it. They're kind of scrambled. But a big thing that was sort of used in this was the probability method. And again, it's, if you look at it in sort of like a pi sense, there was a fraction here that I saw, an example that was basically saying, where did that go? Let me see here. I have the textbook open on my phone, trying to find it. It was basically like the denominator of a fraction would be how many pieces are in a whole, and then the top part are how many pieces that are being used or not used or whatever it is. And so trying to find a number for that. And then as far as like, I know I'm skipping ahead here, but exponents, I believe, were like, they basically were like reversed squares. Yeah, and so that was the big thing, where it's like x squared would be x times x, but whatever x times x equals, the square root of x, or the square root of x times x, would be the result of that. And so that was kind of a big takeaway. I know that seed, it was sort of all over the place. It's been kind of crazy recently, but I think those were my biggest I guess like lessons learned, things that I took away from this last chapter here.
Yeah, that's really good. Yeah.
Mm-hmm.
I think that's all we have to do. Yeah. All right. I will